4 is officially real zeros of polynomial functions. So finding the zeros, specifically when we're not looking at the graph, okay? Really what it comes into is we're going to review long division and synthetic division, okay? Now, we did long division and synthetic division last year. What you remember of them? I have no idea.
Not much.
Do we need a basic long division to get us started?
I'm good. We don't have to do that. It's what everybody else wants. It's been a minute. Sure, we'll do one. We'll hit it with one. Okay, that's a big number.
Now, keep in mind.
Did it go nicely at least?
It does.
Okay, that's fine.
Well, I mean.
If you do it right.
It does for what we're doing. Okay, so we're regressing to 3rd or 4th grade. I think 4th grade was mostly your division. Okay.
That was a couple years ago.
So that was a couple years ago. So whoa, not the calculator.
I didn't want to do the math in my head. I didn't use it to divide.
You can't do a math. You can't do the math with multiples of 25.
It was subtraction.
Oh my gosh, the subtraction.
I was going.
Okay.
I was going the way I was going.
Okay. Still, you don't need a calculator for this, but okay. What do we start here? 25 into
9 first.
9. It doesn't go into 9, so we're going basically 2-digit into 2-digit. 25 into 96. How many times? You can count by 25s. Think quarters.
3.
3 25s, right? Where do I put that 3?
Above.
Above the 6. 3 times 25 is
75.
75. So this is where Logan got lazy?
Yeah.
96 minus 75. 6 minus 5 is 1. 9 minus 7 is 2. So 21. It's smaller than 25, so I must have done something right. Now what?
Bring down that 4.
Drop the 4. How many 25s in 214? 8. 4 quarters is $1. So 8 quarters is $2.
Year.
8 times 25 then is
200.
200. 214 minus 200 is 14, and then
145.
Drop the 5. 25s and 145.
5.
5. Because 5 25s is
125.
125. 145 minus 125 is
20.
20. And
206.
drop the 6.
8.
25s and 206 again is 8. 8 times 25, 200, remainder of 6.
Oh,
Okay. We're not doing a decimal. Nope, not with long division polynomial. We're not doing decimals because we won't be. So you can either talk remainder, or we could say that this is 3,858 and 6 25ths over the divisor, right? So you could say that it is 3,858 and 6 25ths. Okay. But we really want to go back to elementary. You said R6, right?
I like R6.
Those were the days. We don't get to do it quite that nicely, but.
I like this.
Okay. That's your elementary division, long division review. We did the same type thing a year ago, so shouldn't be a little fresh. Yeah.
Sure.
Okay. Our example 1. I'm only giving you one long division example here. You'll have a couple in homework, so we can talk about them if we need to when we go over homework. Use long division to find the quotient and remainder when 2x to the 4th minus x cubed minus 2 is divided by 2x squared plus x plus 1. Okay, couple of setup issues here. First of all, what goes in the box?
2x to the 4th minus x cubed minus 2.
So 2x to the 4th followed by
X cubed
minus x cubed, followed by,
minus 2.
not exactly,
Plus 0 x squared.
We start with an x to the fourth term. Then we had an x to the third term. What should follow an x to the third term?
An x squared.
An x squared term. Does this problem have an x squared term?
Nope, so you gotta put a 0.
No. So we're going to say plus 0x squared. What should follow an x squared term?
An x plus 0x.
Should be an x. I don't have one, so plus 0x. What follows an x term? A constant, which we have, minus 2. Okay? So don't forget, if there's missing place values, fill them in with zeros. It's not that you have to put the zeros there, but it keeps us all lined up. And that is the importance there. Same needs to be true outside. Make sure all place values are there. We're dividing by
2x squared plus x.
2x squared plus x plus 1.
Year.
Okay. As we go through this, yes, we're dividing 3 terms. I don't know what you guys remember from last year. I always just look at the first term into the first term. So I'm asking myself, okay, if I think back to how I say it to, an elementary kid, how many times does 2x squared go into 2x to the fourth? Or how many times does 25 go into 96? But really what we're saying is 25 times what is 96, right? So what I need you to say here is, and I'll do 2x squared times what is 2x to the fourth?
X squared.
X squared, yes? Are you with me?
Yes.
Okay, so x squared is my first answer. Now, where do I put x squared?
Above the x to the fourth.
Not above the x to the fourth.
X to the third, you go down. Wait, what? I'm above x. Because it's an x squared, it's 2x squared. This is
Okay, now,
too much.
okay, options. One option. How many terms are in the divisor?
3.
3. How many terms did I just count down to put my answer?
3.
3. That's one option. Or, notice x squared landed above
X squared.
the other x squared term, right? You can always line it up by putting it above its like term. That would work for you as well. Okay? So are we good with what I did here?
Yeah.
Now what do I do with this x squared?
Put it into the 2x squared. You multiply by the whole thing.
Multiply, right? What did we do with the 3 here? We did 3 times 25, right? So what am I going to do with my x squared? I'm going to do x squared times
2x.
each of these terms. So x squared times 2x squared is
2x to the fourth.
2x to the fourth. X squared times x is
2x. Or sorry, just x cubed.
plus x cubed. X squared times 1
X squared.
plus 1x squared, or x squared. And then what are we going to do?
Just cancel out everything. Put your x squared.
Give me a different word than cancel.
Subtract.
Officially, in long division, you are subtracting. Now, if you've done this correctly, the first term should always cancel out. 2x to the fourth minus 2x to the fourth
0.
does just that, right? What about my next term?
0.
Negative x cubed minus
Oh,
x cubed.
yeah. Negative
So basically, what's negative 1 minus 1?
2x.
Negative 2x cubed. And, wait a minute, something's goofy here.
Yeah.
That should say x squared here, shouldn't it?
Yeah.
Sorry. Hopefully I said x squared earlier. I don't know what I said. I definitely didn't write it right. Okay. And guys, I knew something was goofy because I didn't have like terms lined up. Okay. That's how I knew something wasn't right. 0x squared minus x squared. So 0 minus 1, basically.
Negative 1.
Negative 1
X squared.
x squared. And now what?
0.
Drop down your 0x and repeat the process. Is this coming back to us?
No. I'm not gonna lie.
Okay, I'm getting some nods that like, yeah, and there's some of you are like, yeah, no, not a chance. Okay, now repeat the process. So this time, it's still 2x squared, but this time what are we trying to take it into? The negative 2x cubed. So 2x squared times what is going to give me negative 2x cubed? Negative x. Now, if you're struggling with this multiplication, fill in the blank, what's the opposite of multiplication? Division. Could you just divide those two terms?
Sure.
Yeah. What is negative 2x cubed divided by 2x squared? Negative x. What do I do with that negative x?
Put it up top.
Put it up top.
Above the 0.
Should go in your next open blank, which that does line up above the x's. Now we're going to take this negative x and we're going to multiply it. So negative x times 2x squared, negative 2x cubed. Negative x times x. Negative x squared. Negative x times 1. Minus 1x. Or minus x. And now we're going to subtract. Negative 2x cubed minus negative 2x cubed. Cancels. Negative x squared minus negative x squared.
Cancels.
Also happens to cancel. That's not a guarantee, but it did. 0x minus negative 1x.
1x.
Positive 1x. And we're going to bring down the minus 2. I brought down my last piece. Can I go again?
No, it's your remainder.
I've got 3 terms here I'm dividing by. There's only 2 terms here. I can't go again. Because we ended up with 2 terms canceling out here, I ended up being done. And so x minus 2 is what we would call the remainder. What's the vocab word for our answer up here?
Quotient.
Quotient. Did you know that before I wrote the Q?
Yeah, because it was in the use the
Okay.
division to find the
Quotient and remainder. Fair enough. Now, if you have to express this all as one answer, which very well might be what homework does, remember, how do we put this all together? We have x squared minus x plus
x minus 2 over
remainder of x minus 2 over the
original
divisor.
divided.
So over the 2x squared plus x plus 1. That would be your full out answer there. Okay?
I guess.
Okay. Now, that's long division. You're going to see a couple of long division problems in homework. We can touch base more on those if we need to. Okay?
We'll probably need to.
We might. I may have regret only having one long division example in here, but okay, we're going to go down and talk about the remainder theorem. Now, the remainder theorem talks about if a polynomial f of x is divided by, so like a linear factor here, then the remainder is r equals f of k. And so what we're talking about here when we talk about the remainder, and we did this last year, f of k is when you take your k value and you can just plug it into the equation. Okay? It's a direct substitution method. We'll review synthetic division tomorrow, and you could also use synthetic division to do this. But they're asking us to find the remainder. Now, let's look at these examples. Find the remainder when f of x is given, and in this first one, when it's divided by x minus 2. Keep in mind, this is of the form x minus k, yes?
So you're
What is my k value?
2.
My k value is 2. You can also think of it, if you remember what I did last year, x minus 2 equals 0, and then when you solve that, you're using 2, yes?
Yep.
In order to find the remainder, all you have to do is plug 2 into the equation. So f of 2, yeah, we're leaving the hard stuff behind for today. So 3 times 2 squared plus 7 times 2 minus 20. 3 times 2 squared is 12 plus 14 minus 20. 26 minus 20 is 6. What is this I just found?
Your remainder.
Your remainder. Now, could you have done long division to find that?
Yeah.
Oh, yes, you could have. Could you have done synthetic division, which we won't review till tomorrow? Yes, you could have also done synthetic division. Talk to an Algebra 2 kid. They just learned synthetic division. They can remind you. Okay. Ready for B?
I think I'm ready with
Find the remainder. What are we using here?
-1.
Okay. Basically, you're always using the opposite sign when they present it in that x plus 1 form, right? So plug in -1. 3 times -1 squared plus 7 times -1 minus 20. What do we get? What'd you say?
-24.
3 minus 7 is -4, minus 20. I can go with -24. And what is that?
Your R.
That's your R. That's your remainder. And
One more time.
one more. If it's x plus 4 is the factor you're dividing by, what do we plug in?
Sorry, -4.
We're going to plug in -4. So plug in -4. 3 times -4 squared plus 7 times -4 minus 20.
0. Or sorry.
Oh,
-4 squared is
16.
16 times 3 is 48. And then 7, all that's -28 minus 20. 28 minus 20 is -48. So 48 minus 48 is 0.
are you guys with them?
Yeah.
Remainder, do the math, remainder is 0, yes?
Year.
Okay. Now, that is your remainder theorem. Gosh darn it, I set this up bad. Okay, well, because now I put this next part on the next page, and I shouldn't have. Okay, I'm gonna fit it down into here probably.
Can you pull it up?
I can pull my notes up, I can't pull my writing up. I would lose all that writing. Okay, now, hang with me. Factor theorem. Okay, remainder theorem gives us an easy way to find the remainder. The factor theorem says a polynomial function has a factor if and only if f of k equals 0. What's f of k a fancy word for?
X minus R.
That's your r. So this is saying that a polynomial, something is a factor if the remainder is
0.
0. Because factors are numbers that divide into something evenly, right? So, state whether the following are factors of this function f of x. First of all, what do you notice about f of x?
It's the same thing, man.
Is it the same f of x we just
It's the
used?
same exact thing.
It is.
We already have the first one done.
We already have 2 of these done, if
2
I
of these
recall.
done.
Which
Oh,
is
yeah.
why I'm regretting.
Yeah, fair enough.
I'll have to set this up different later. But, so, x minus 2.
Not a factor.
Is it a factor?
Got a remainder of 6.
Okay. So if you look up above, we found f of 2 to be 6, which means we found the remainder to be 6, yes?
Year.
And are you catching on? We already did that work, yes? It's the same problem from above. And so 6 does not equal 0, so this one is
Not a factor.
not a factor.
Boom. Yeah, we've done this one too.
Are you guys good?
Mhm.
Okay. What about x plus 4? Is x plus 4 a factor?
It is.
How do we know it's a factor?
Well, because after you do the math over there, you find out the remainder is 0, which means it's a factor.
Okay. We already did f of negative 4 earlier, and we got 0. So that means my remainder is a 0, and that means that this is a factor. Okay, and the work from up above. Okay, C. What about x plus 3?
It's not a factor, or not, whatever.
What do we have to do?
The math first.
We're going to have to do the math. What is it we're going to plug in?
-3.
Negative 3. So 3 times negative 3 squared plus 7 times negative 3 minus 20. (27 minus 21 minus 20)
-14.
is negative 14. So we just found the remainder to be negative 14, and that what?
Not factor.
Does not equal 0. So this is
Okay.
not a factor. Okay, tomorrow I will do this very last problem. Remind me. Although, look at it as you're packing up. Write a function of degree 4 and leading coefficient of 2 that has these zeros.
Never seen that equation before.
Forget leading coefficient of 2. Degree 4. Did we just do something like this? It was in yesterday's notes. Was it in the homework?
And you just put a 2 on the
Leading coefficient means you're going to have a 2. So what about 0? That's going to be an x minus 5, x plus 5, the 4,
X minus 4.
x minus 4,
X minus 8.
and the 8, x minus 8. And a leading coefficient of 2 just means
2 times X.
it's 2 times x, which is 2x.
So this homework will be due Monday.
Yes. Homework will be due Monday.
That's your answer.
Okay. Now, we will, remind me, tomorrow, start off by multiplying it out. Okay? We'll do that in the other part of the notes tomorrow.